Okay, wonderful. So, okay, let's get ready to start. So, good morning. Thank you so much for coming here to JNation again. If you've been to the keynote, I already welcome. If not, I will be welcoming again. So my name is Roberto Cortez. There's still a couple of seats here if you want to sit. That's fine. There's also a couple of other chairs over there. So thank you so much. It's a really nice room. And let's take a picture first, right? Will be fun. So let's do it like this. Say cheese. Oops. Come on. Raise your hands. You don't seem very excited. And you know, my brain is actually functioning only at 10% today. And I don't want to put any excuses. This session is to replace someone else's session that couldn't travel for COVID. So I haven't got time to prepare anything. So I'm gonna wing everything. So please, 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 don't be mad if I mess up. Okay, anyway, our agenda for today. We're going to look a little bit about the state of the art of distributed tracing. And we're going to talk about something called OpenTelemetry. Maybe you heard about this, maybe you haven't. But let's go a little bit over the basics. And I hope that even if you heard about that before or not, well, you learn a little bit about it today. And maybe you can apply it to some of your projects in the future. Okay, first of all, microservices. Who's doing microservices today? Okay, pretty much everyone. So actually, I'm doing microservices talks for like 5 years. When I asked this question, like 5 years ago, it was like only like 10% of the room. Now it seems like 80% of the room. So I'll ask the question in another way. So who is not doing microservices today? Who's not doing? Okay, just maybe 10 people. No, but there is no difference, right? Between doing a microservice and a monolith. It's just the pile is just a little bit smaller, right? Now, the issue with microservices, and I mean, we all love, and maybe you know about it, maybe you haven't. I'm not going to go about the story of microservices. I mean, they were popularized by Netflix. Now, the issue with this kind of architecture, I mean, it gives us a lot of good stuff, but on the other hand, it creates a And one of the additional complexities we're going to talk about is how do you track something on your system, right? When you have multiple services and they have to connect with each other and they have to talk with each other, you have to be prepared to answer a lot of questions, right? When you have something that goes okay and go on the happy path, that's great. Everyone is happy. Everyone enjoys that. But what if something goes wrong? That's when someone's going to call you at 2 a.m. saying, this is not working, why? So you have to be prepared to answer a couple of questions, like who causes the issue, right? When did it happen? And where in the request? And when I'm talking about request, I'm not talking about an HTTP request. Of course, it can be an HTTP request, but I'm talking about more as a more abstract concept, as like a transaction that's happening on your system as a whole, right? So everything is abstract concepts here right now. So the other day I went to go and I wanted to buy a PlayStation 5. Well, not really. It was just interesting to put on the talk. Now, this you can probably not see that well. But what you see over here, so basically what I did, I pick up my browser, hit one of the detail pages of Amazon, and these actually are the number of requests. Just requests, not calling for a CSS, not calling for HTML. Those are requests to the server just to build the detail page when buying a product. How crazy is that, right? So if you're not familiar how Amazon builds their stuff, they actually build it with micro front ends, meaning that they have like a component for comments, they have a component for buying the product, they have a component for showing the detail. And all of those are like developed by different teams, and then they have to assemble the entire page. And of course, if they want to show the comment sections, right? They have to call a particular service to do it. Why? They have to call another service to do it. And then in between, and this is only the initial request, right, to build the page. I have no idea what happens later. I don't have that visibility. Now, a couple of years ago, Uber, one presentation of one of the Uber technical leads, came up with this slide. So this slide is even more impressive. So the pink lines actually represent like a happy path when you're requesting a driver to Uber. Now look how many jumps and calls are being done inside the Uber system to be able to do that. But what's more impressive about it is the number of dots. So these dots represent services on their system. Isn't that crazy? How the hell do you know when something goes wrong? What if something goes wrong here? Do you know that it went wrong there? What about here? Right? It is exhausting, right? So what you will do in that case? Do you go and check the logs on every server? And then you have to try to figure out when it broke, and then you check one server, then you check the other, and then if you have like multiple nodes, are you going to check the multiple nodes to see which one failed? I mean, this is completely crazy, right? So that's where distributed tracing comes into place. And the idea is with distributed tracing, you're able to track the progress of a certain request, right? This can also span multiple events and even transverse boundaries. When I say transverse boundaries, we are not confined on only looking on what's happening on your system or your application, but the system as a whole, including things like databases, messaging systems, and so on and so forth. So the idea is that you're able to trace the entire request that happened, so we'll be able to understand when something goes wrong. Okay, so I think we established one of the issues of using these architectures, and we've seen that most of you are doing this right now. So maybe that's why you came to this session, because maybe, are these issues that I talked to, these problems, are these familiar to you? Do you have any issues like this? Right? Raise your hand. I mean, we are in a safe environment here. No one is going to blame you. That's fine. Okay, you have those issues. Wonderful. Okay, so I think that distributed tracing can help you fix some of these problems. Not everything, but it will help you with some of the things. So let's come with a couple of concepts about distributed tracing. So distributed tracing, you have something called a tracer, right? And then on the tracer, you have things called like a span context. So the span context is something that allows you to have information associated with whatever thing you're tracing. When you're tracing something, there's also what we call a root span, which basically is what we use to represent what created the initial request. And then everything's going to go from there. And then you can have even those relationships between parent and child. So a span represents an action on your system. It can be calling a service. It can be doing a database query. It can be putting something in the Kafka queue, right? And the idea is that you should be able to propagate this span context in the way that you'll create this really interesting action or this interesting story about a user or whatever other action happened on your system. So let's go with a quick example because I think that it makes things a little more clear. So let's go with the traditional buying book example, right? So I want to buy a book, right? And of course, I mean, you can have multiple steps over here. I just came up with a few ones. So you buy a book. The buy book thing is your entire transaction. And I'm not talking about database transactions, just a transaction as an abstract concept. And then you have to process the payment, right? Usually when you process the payment, you have to lock the credit card amount to be deducted later. So basically what you have over here is all of these here are actually the spans of your trace, right? And the buy book is your root span, so everything that's going to be traced on that particular transaction. So everything that you have inside are the individual spans that represent the things that happen on your system. So after processing the payment and locking the credit card amount, then we can even issue things in parallel, right? Your system can issue things in parallel, like to say, it can generate a shipping label, it can create the invoice, and it can update the stock. And those pairs or those actions, they represent points in time, and they can take from a few milliseconds, or they can take seconds or milliseconds, even days or hours, right? So for instance, if you look, most of the times when you order a book, you're not going to receive it instantaneously, right? So you have to wait for a few days, right? So not every system is instant. So meaning that after maybe a couple of days, the shipping order is put into the system, it generates a tracking order, and then your credit card is deducted by the amount of the book. Does this make sense? OK. Now, the idea with tracing is there's going to be a unique ID, or depending on whatever strategy you will use, but for now, we'll just think about your unique ID. That's going to be generated when you start a transaction, and then that unique ID is going to be propagated across your entire transaction as well, or request. This will allow to be able to know exactly what happened in that particular transaction, even if a certain action is only executed 2 days later, 3 days later, even a month later, right? So using that transaction ID, or actually in this particular case, it's called the trace ID, you're able to build a history of that particular transaction that happened on your system. And with this information, then you know when something goes wrong. Or even when something goes right, you may even use it to understand, let's just say, even performance issues and things like that. Of course, this will only work if this trace ID is propagated, right? If the trace ID is not propagated to a system, then, of course, you're going to lose the trace, and you only have tracing information until that point. So the idea here is you have a trace ID, it's propagated across your entire system, and then you can build this history. So now this is where OpenTelemetry comes into place. So now we introduce the problem statement, we introduce some of the concepts, and now let's look into some of the technology. So does anyone here have heard about OpenTelemetry before? OK, a few. Maybe Open Tracing. OK, maybe more. That's wonderful. So OpenTelemetry is actually a merge between Open Tracing and OpenSenses. Does someone heard about OpenSenses before? Yeah, just a few people. It was not that popular project. But the idea was a few years ago, sorry, there was these projects, Open Tracing and OpenSenses, that were working on the same problem statement like this. And later on, both communities decided to join together and try to make a standard effort to offer OpenTelemetry to everyone, right? So OpenTelemetry is actually a project founded and hosted by the Cloud Native Foundation, and it's open source. Sorry. And a lot of the vendors that you will expect are working on this project. A lot of the cloud vendors like Amazon, Microsoft, Red Hat, but also vendors that have tooling on that space. Things like Datadog, New Relic, Splunk, Prometheus. So all of these companies are working together on OpenTelemetry, which I think is great, because it means that they're trying to come up with something that's going to actually work across all of these boundaries and across all these tools, across all these clouds in a very seamlessly way, instead of everyone having their own tracing or their own telemetry information. Ideally, this what we'll have over here is a standard that everyone will use, and it won't matter if you're running things on Amazon, if you're running things on Azure, or if you're monitoring your stuff with Datadog or New Relic. The idea is that with OpenTelemetry, across all these boundaries, you'll use whatever you want, and you'll still be able to get the exact same data. Now, OpenTelemetry is not only about tracing. It also includes metrics and logging. I'm not, so metrics and logging is out of the scope for this talk, especially because when I was thinking about doing this talk, and I came with this talk maybe a few months ago, I thought that in trying to include everything was just going to not have too much detail on each of them. So I just prefer to focus on the tracing part, and later on, I'll come up with sessions about metrics and logging as well, and so we'll just focus on one. But for today, it's only about tracing. So maybe next year, I'll make one about metrics or logging. And one of the ideas with OpenTelemetry is they want to be sure that they don't get in your way of your application. And we're not talking about only about Java applications, even though that's my background. We're talking about so all the things that I explained over here, have I ever talked about the language before? No. Is any concept here tied to any language? No. So on OpenTelemetry, this works with pretty much every language. So they have support, or they give you APIs and implementations for things like Java, JavaScript, Ruby, .NET, whatever you want, right? Because these concepts are abstract, right? So all these languages have the OpenTelemetry API. They follow the standard, right? And the same way that you will do with having OpenTelemetry available in one of these cloud providers, you also have it with multiple language. So you can mix services that are running JavaScript on one side, using Java on the other side, and then the tracing propagation happens from one to another, and in the end, you'll see everything just quite nice. Now, the OpenTelemetry is, and now this is a little more specific with the language. They try to not get in your way. So a lot of the examples I want to show, that I'll be showing will be in Java. I wanted to put the JavaScript example as well, or a Ruby one, but I didn't have time, so I'm really sorry about that. But the idea is that OpenTelemetry will instrument your application, so you don't have to change your code, right? And you'll get tracing data out of the box without you having to change a single line of code. And I'm going to show a couple of examples and demos with that. OpenTelemetry also provides you what they call the collectors API or collectors thing, which basically what it's going to do is it's going to collect all the data that OpenTelemetry is generating, and then you can configure the collector to send this data to whatever tool you want. Grafana, Prometheus, Splunk. You can even you can configure to send it to all of them if you want. And then you can, of course, use this data to consume it. And so to have like a little schematic on things. So let's just say you have a couple of backends, right? You have your application. You have like a library over there. You can instrument your code, or you can just do calls directly to that library. That library will send the information to the collector. And you can even have like multiple agents will just collect all this data, and they will send it to the collector service, and then from the collector service go to whatever place. So this works quite nice. You can have multiple nodes, you can have multiple collectors, and you can even choose which data you want to collect. Okay, so what can you trace? Virtually everything, right? Networking information, right? Including HTTP clients and servers, even IP information, TCP information, so you can collect all that data. Databases, you can collect everything. So most modern, I won't say all the databases, but I guess most modern databases Telemetry support. They put the support directly on the driver. So in most databases, what you have to do is just change the driver to the OpenTelemetry driver, and you start getting tracing information from there. And I know that there is tracing drivers for Postgres, MySQL, Oracle. So most of the popular databases are supported already. RPC, also supported. Messaging queues, things like Kafka. Kafka already gives you support for OpenTelemetry. Exceptions, right? So when you have an exception happen in your code, you can also trace that. Virtually, you can trace everything. And a lot of the libraries, they already do that work for you. Okay, now this is a little bit more specific on the Java side. So what one of the things the OpenTelemetry gives you is the agent instrumentation, right? So the idea is with the agent instrumentation is you just hook up a Java agent on your Java or a JVM application. You just start the application with the Java agent, and out of the box, you get tracing data without having to change a single line of code of your app, which is great. And other languages, they have similar means to do that as well. But unfortunately, I haven't explored other languages that much yet. Now, there are some downsides of this. One of the downsides is this is limited to the libraries that OpenTelemetry support, but they do have a lot of support already. So if you're on the Java world, things like Spring, Liberty, Wildfly, those application servers, but other things like Vertex, REST Easy, so a lot of, even Camel, so a lot of these libraries are already being supported by OpenTelemetry out of the box, and you don't have to do anything on your own. Of course, you can even create your own agent if you have like in-house libraries that, of course, OpenTelemetry doesn't know about. You can create your own library to do that, and then you just hook up on the agent, and you're fine. Library instrumentation. So this is another way to do it. And the idea is that the library will provide the OpenTelemetry support for you. So it just includes the right dependencies on your project, and this works with any language. So in this particular case, again, with Java, so if you're using Quarkus, if you're using Spring, they already have support for all of this. So I'm actually working in the Quarkus team, and I wrote all the OpenTelemetry integration in Quarkus. So if you're using Quarkus and if you find bugs over there, you can blame me. And this also integrates with the agent. So you can start your agent with your application, and then library will also generate telemetry data, and all of them will actually work together, and they kind of merge all this data together, and they can collect information from both places. On the library side, most libraries are done in a way that's going to work transparently to you, right? You just add a library to your app, and the library will start collecting data automatically for you. So for instance, in Quarkus, that's how we do it. You add the OpenTelemetry extension, and then we automatically start collecting data straight away. And then, of course, you have the manual instrumentation, which basically is you just use the OpenTelemetry API directly on your code. And again, this works for every language. You access the OpenTelemetry API directly, and then you can do all the things that I was discussing, for instance, in the book example. You can get access to the current span, and you can start adding attributes. You can create new spans at your own discretion, right? So then, in that particular case, you have full control. I'm not going to say that you shouldn't do this. It will depend on your use case, right? But ideally, what you want is the library or the agent things for you, so you don't have this additional work on your app, right? And then you have the exporter. So I talked a little bit about the exporter previously. Let's go a little bit deeper now. So the exporter is basically just receives all the information. It processes kind of like an ETL process, right? It runs with your application. So now you start to get a little bit in the bad parts, in the sense that, of course, there's going to be a performance hit on your application, right? Because you're collecting all this data. I cannot tell you what the performance hit is going to look like, because it will really depend on the app. But sometimes you're talking about between 5–10% to 20%. So it really depends. But again, you don't have to have OpenTelemetry hooked up on every node. Right? So you can just pick up which node you want to have OpenTelemetry. You can just turn it on and off. So it really depends. And then OpenTelemetry came with this, what we call OTLP, which is the OpenTelemetry protocol. And this is how all these cloud providers, all these other tools will communicate together. So that's what I'm saying, that the idea with OpenTelemetry is to just bring everyone together so they can share all the data, so you're not completely locked into a particular cloud instance or a particular tool set and be afraid, oh, I cannot use Amazon now because I'm already on Azure, they're tracing their stuff, and if I move over there, I'm going to lose all my tracing information. No. So with OpenTelemetry, the idea is that it will work seamlessly across everything. Now, this is a theory, right? In practice, it may not work that way yet, but that's the goal. OK, so now let's try to do demos. And now I have to pray to the demo gods to make sure that this will work fine, especially because I haven't practiced a demo in like a month. So I think I have 25 minutes left. Is that correct? Yeah? OK. So let's see. Let's move here to my terminal. Let's increase this. Can you see this? Wonderful. OK. So let's go here. So these are a couple of examples that I have. OK, so let's go with the agent first. OK, I'm going to run Docker Compose. So what I'm doing right now, I'm running the hotel collector and a Jaeger instance. So the idea is that, of course, I'm going to collect telemetry data with the hotel collector, and then the hotel collector is going to send this data to Jaeger. Now, and because I don't remember this, let me just do like this. OK, so let me copy that. Oops. So what I have right now is I have an application. I'm running it with Jetty, and I run it with an agent, right? So let me open this application on IntelliJ. There you go. No worries. I'll put it a little bit bigger. OK. So, oops. Let me open this. OK, there you go. So the example that I'm showing over here is the agent. Do we have no Java people here? No Java? OK, sorry about that. This is Java. But it's all, I'll try to make a JavaScript example like next time. But it will work the exact same way on other languages. So I'm not going to explain the code, but what I want to show you is, so let me take it out. So this is just a REST endpoint, right? There is no specific APIs here. It's just using JAVAX, REST endpoints. It just generates a random number. The idea is we'll generate an ESPN number for a book. All right? And well, I have here an application. Again, there's nothing specific out of this. And here it's just injecting a configuration. So there is no, this is pretty standard, right? OK. So let me go to my web browser. And I don't remember where I have this running. I think is, well, I think it's 8080 actually. So 8080 numbers generate, I think. OK, there you go. So you see this now generating a few random numbers. And now I'm going to go and hit Jaeger. OK, it's too big. And now you see, I haven't done anything on the app. I just have like a really standard app. I run it with Jetty, running with the agent. And I already see that I have an application called Number API on Jaeger. So I can just look at it. I'll do like find traces. And I'll see some information already up here, right? So I can just go here and expand it. And I'll see, OK, numbers generated. Is it familiar? That was the endpoint that I called, right? So it's showing up over here. And I can even expand this, and I'll see, OK, this is actually using the OpenTelemetry Jetty API, or the Jetty library, the route numbers generate. It returned a 200. Let me just put a little bit bigger. It returned a 200 status code. I call the get, right? So I have all this information. And if I even expand it further, I can see this was actually the fully qualified name of the class it was called for my REST endpoint, right? So I haven't changed the application one bit. I just started with the agent, and I'm already collecting information from what I'm doing. So the idea here, even so, the idea here is even if you have legacy applications that you don't want to change, you may not even have the code to change it, right? You can still hook up the agent or the OpenTelemetry libraries and start collecting this information. So yes, so this is one way to do it, and it's the most out-of-the-box way to do it. So now to look a little bit into the code, and this again is a little bit specific on Java. What I have is on my Jetty startup, I just plug in the Java agent that's going to collect the OpenTelemetry data, and that was the only thing that I did to my application. Now, you have the OpenTelemetry collector, and this is going to be the same for every language or library. And then you'll see, let me just increase it a little bit. Oops. OK. Now you'll see, you'll set up some configuration from the hotel collector, right? And one of the configurations you'll see is the exporter. I'm saying, please put all the information into Jaeger, but let's just say that you wanted to use Grafana or Splunk. You'll just come over here. Then you'll set the Splunk configuration here to put the data over there. So yeah, so there's a couple of other configuration here. But the idea here is with the collector, you can even send information to multiple systems at the same time, not only Jaeger. OK, so this was a very small example. So let me kill this one. And I'm going to run another one. So this is the library. I'm going to do Jetty run. Just Jetty run now. And let's see what I have. So this is running the exact same application. It's still generating a couple of numbers over there. So let's go and find traces. Now we'll see a little bit difference. Now remember, there was like 2 spans in the other one with the agent. Now you'll see actually seeing 3 spans, right? So let's go deeper over there. So you still see the numbers generate. Now you'll see that actually the library is the small y OpenTelemetry. So that was one of the ones that I wrote to use on Cortez. And the idea over here is that I just added the library into my application, and the library is collecting the stuff for me. And you even see some weird stuff like over this, which is the span new. And you see that's the library name. That's a couple of keys and values that I'm recording. So let's look a little bit into the code. So if I show you this, so the configuration is exactly the same. And the application is pretty much the same. But you'll see here a couple of different things. So you'll see this with span annotation, right? And you even see this is not coming from any specific library. It's actually coming from the OpenTelemetry code. So what I'm doing over here is I just annotate the method with span, and it will just automatically span that method. It creates a new span, and then it records the method name. You can even record the parameter names of the method, and you're done. Or you can even use the programmatic API. So in this particular case, what I can do is you can grab a tracer. In this particular, I'm just using @inject, but you can also do it like this. So tracer dot, was that tracer? I can't remember. But you can do span. Sorry? Global tracer. Very good. Do you want to come do a presentation, please? Let me see. Is that the global tracer? No, it's global OpenTelemetry. Sorry. And get tracer. That's the one. So you can get the tracer like this. Or you can do span current and get the span like this. But yeah. And in this way, you're able to retrieve a programmatic API for the trace, for the span, and then you can just control whatever you want. You can set attributes, you can set the span kind, well, you can just play, and you can even put your own application information into the spans, create a new one, or enroll in the current one. So that's another way to do it. Now, And this I'm going to really need your help. So please pray with me to demo gods, because this is really a hard demo to do. And especially because I haven't prepared it, I'm quite scared. OK, let's see if I'm able to do this. Library, so I killed Jetty, I think. Let's kill Docker. Let's kill Docker. Docker compose. Well, let's go to the agent. Docker compose. Down. OK. And now I have to go to this other place. Personal. No. OK. And Quarkus. So this is actually using Quarkus, but I'm not even going to show any code. We're going to do a challenge now. And let's hope that everything goes OK. OK. So I'm going to start up a bunch of things over here. I'll probably need to pick something from here, just to make it a little bit easier. OK, let's start all of this. OK, cool. I should probably put that in detach mode. Sorry about that. Usually, I already have all of this set up before. So let's go again. Quarkus Playground. OK. Services. Number API. OK. Quarkus. Dev. OK. Playground. Services. Book API. Quarkus Dev. OK. This started up OK. This one's still starting. Well, I think it should start. OK. So let's see if this works. So now I'm going to go again to localhost 8080. And the challenge that I have for you is, OK, this one is running. So I'm gonna run the application, and I have this Swagger UI. I'm gonna run a couple of endpoints, and I'm not gonna show any code to you because we're gonna try to guess what the application is doing, right? So I have here a post. So let's do a post. I actually have to authorize myself first, and of course, I like to use Goku, but I'll use a Cabra. There you go. And let's do a post. I'll do an execute. And I got the 201. That's fine. I have the response body over here. It seems that I was able to create the book. So let's look into Jaeger now. Did I kill Jaeger? Or did I? Well, apparently I. OK. So now you see I have like book API, number API here on Jaeger. And let's go and check into book API traces. And you see there is like 6 spans, right? So let's dig on that. So the first one is I'm calling /books. And I did, do you remember which action or operation I executed? Post? Yeah, so let's see. I got the 201. And I should have a post here somehow. There you go. So OK, everything's nice for now. And now I see there is actually a select over here. See, there is like I have a database, right? So I'm actually storing the books on the database. And you see a select. So we've seen that it is selecting a sequence. So maybe, even I haven't seen the code, you always know, OK, I have a book. Now I have a database. I've seen there is a so you're already able to know that I have a database without, I haven't told you my system, but you know that I have a database. And you know it is a Postgres, because it's right here. It's a Postgres. And you even know the connection string, right? And you know it's running on localhost. The DB username is Quarkus. So that's the username that I use to my database. So yeah, so I know that I have this database. It's selecting here. And then you see that there is this numbers generate that's being executing on 8090, which seems to be on another service. And you see this is a client. It's coming from Cortez as well. And now you see this thing on a different color. And now you see that this book API actually seems to be calling another service called number API. Remember when I told you that number API was used to generate an ESPN for a book? So maybe things are starting to make some sense here. So let's go and extend number API. Now we'll see, OK, this is Quarkus OpenTelemetry. So it's running a Quarkus application. I got a 200. And it's called number generate. It's called a get, right? And that was it. So just by looking into telemetry data, I was able to figure out, oh, there are two services involved in this execution of creating a book. I see also a database involved in the call. And I can even see now, I see there is an insert of the book on the database. Again, you even see the query here. So I'm able to see, OK, I'm inserting a book with author, genre, ESPN, the publisher, and so on and so forth. And apparently, there is an update over here. I have no idea why. That's probably not a very good practice. But doesn't matter. I mean, but this is on purpose, right? Why is there an update when you're creating a book? Maybe you have messed up your code somehow. But the tracing information not only works when accessing errors, but even when things go OK, you're able to see exactly what the system is doing, right? Even spanning, again, as I mentioned earlier, multiple layers, right? Not only the application, but also the database, right? Was that fun? Trying to do this, backtrack to the application. Well, I didn't show a single line of code. I will show it, but right now I haven't shown a single line of code. So there's still 8 minutes left. So let's go with the last demo. So the thing I'm going to do right now is I'm going to kill number API. So kill it. Let's try it. What do you think is going to happen when I try to create a book? Sorry? I got an error. OK, I got an error. Any other takes? OK, let's see if we get an error. So let's go to my Swagger UI. I'm going to hit execute again. And oh, I got the 500. Apparently, I got an error. That's not good. Why did I got an error? So let's see here. I mean, this is crazy. I can go and look into the logs, and yeah, it's a pain. But I can go here to Swagger, to Jaeger, and let's see, find traces. And now you see I have an error over there, right? So look, I mean, I was trying to like go on the logs and try to find it. I mean, it's a pain, but I go here and I say, oh, there's an error over here, and I can definitely try to find it. Well, it's not really easy, but let's click on the error itself. But you see, you got the 500, right? And well, the stack information should be here as well. Now, let's see. Actually, this should not give an error. Let's execute this a couple more times. Oh, I got to 200, 201 right now. You see, there is this ESPN fallback over there. So apparently, my system was able to recover from that error and was able to have some sort of fallback to another thing. So now let's look into Jaeger UI again. So let's look into the books. And now I see 7 spans, right? So let's dig into this. So I see there is like an ESPN generator fallback handle right there in the traces, right? So I can expand that and see, OK. So apparently, this ESPN generator fallback handle was called somehow. And then I see that these books fallback, actually, apparently, there is a Kafka queue involved somehow. I still don't know what it is. But I know that something was sent to this fallback queue for books. And then I expand this a little bit more. I see that, OK, so again, the Kafka queue consumed whatever went to that queue. And now I see there is this ESPN generator fallback ESPN. I expand that again, and apparently something was executed over here. And now I see there is the select of the book and the update of the book, right? So what happened now? Now it seems there is some sort of fallback on the code that even if the number API is not running, it will send the book to some sort of Kafka queue, and then the Kafka queue will just get whatever came from that send, and apparently update the book SPI. Look how powerful this is. You haven't seen a single line of code, and just by executing a couple of actions, you're at least, even if you don't have the entire concept or context of the application, at least have a rough idea of what the application is doing. So please be honest with me. Who in here in the room actually have to start running a new application, start to hit a couple of buttons, and have no idea what was going on? Yeah. And what about this? Do you have an idea what's going on? At least a rough idea now. But the interesting thing over here is that you can actually link the information that you get from the tracing information with your code. Now I'm going to show the code a little bit in the last 4 minutes. So let's do it very quick to see if we get a couple of QA. This is not the correct code. OK, so that's it. So let's again look into what we have. So we see that we have this ESPN generator handle, and this is coming from internal. So most likely this is a method, actually. So let's copy this, and I'm going to search it on IntelliJ, and bam, I found the class name with that information. So now I can look into this and say, oh, this is the code that's being executed in that particular span, right? And I can actually, so this is what tracing is all about, right? So you can trace the actions happening in the system to your application. And you'll see, OK, so apparently there is a fallback handler being implemented. It's injecting an emitter. So this is a channel. Basically, it's the Kafka queue that's going to be invoked. So you'll see there is an ESPN fallback over there. And then it will send a message with the book. OK. And let's keep digging a little bit more. And then we'll see this ESPN generator class. It's over here. And now you'll see, OK, so this was the one that's calling the REST client endpoint from the number API. Because it didn't work out, it then invoked the fallback. Right? And now you'll see, OK, there's a fallback ESPN over here. And that's where the book is updated. And that's when it's, well, instead of calling the number API generated the ESPN, I'm just setting up here directly. So the last thing, the last really last demo, I have to do this really quick, is I'm going to execute. I don't have like a big timeout, but you'll notice, let's see, really quick, you notice that probably that was not quick enough. I have to increase the timeout of this. So execute, did that work? OK, let's execute it again. OK, find traces. Oh, that's not working, apparently. Oh, you see 4 spans. Why 4 spans? Any idea? Let's hit again. Well, 7. What happens in Kafka? It's asynchronous, right? So what happens over here is that, remember the trace ID that I told you about at the beginning? So trace ID is propagated to the Kafka queue, right? And even if the Kafka queue is running asynchronously, then when it finishes, it will put the span into the collector and exporter. And because the trace ID is the same of the entire transaction, then it will be associated later and become the entire thing that you executed, right? So again, even if you have asynchronous things, even if they take days to execute later, they will still be part of your trace, right? And I think we're pretty much out of time. So I don't have the link over here, so I'm probably going to skip QA. But all the demos that I showed, they're on my GitHub account. So please search GitHub Cortez, and you'll find all the demos of OpenTelemetry. And because we need to be mindful of time, let's move out, and I'm happy to take questions in the lobby if you want. So thank you so much for coming, and I hope you enjoy the conference.